Okay, so you should have just had an audio message that said that the meeting is being recorded. Go ahead and click OK or continue or whatever the option is, just to acknowledge that. And we will get going here. There we go. I don't know why my slides don't want to advance. Fun stuff with live workshops. So again, welcome to this episode of Map Time Davis. And also this is cross-listed with the Love Data Week for the University of California. So I'm really happy to have you all here. Let's jump right into what we're doing. Slides need to advance. All right, sorry, you guys don't see it on my end. I'm pushing the button to advance the slides and they're just not going for whatever reason. Okay, so today's teaching team, who are you going to be interacting with? So my name is Michele Tobias. I am the geospatial data specialist at the UC Davis Data Lab. I'll tell you more about what that is in a little bit. For helpers today, we have 3 people who I work closely with in various places, and I'm really happy to have them. So we've got Naomi Kalman, who is UC Davis staff in various departments, including environmental science and policy and earth and planetary sciences, and a Data Lab alum. We also have Jared Joseph, who is our graduate student researcher at the UC Davis Data Lab, and then Alex Mandel, who is a UC Davis alum, staff previously as well, and now currently works at Development Seed. So again, thank you to you guys because you're going to be really helpful. This is the team that's going to be teaching today, both verbally instructing and also helping out answer questions in the background to make this run really smoothly. So big thanks to everyone. So what is Map Time? For those of you who are coming from all over the UC, all over California, other states, and I know we have a couple people who've registered who are international. You're probably thinking, what is this slide at the beginning? So Map Time is literally time for maps. It started in San Francisco with a group of folks who loved working with spatial data, but just didn't have time for making maps. So they started a meetup, and that idea kind of spread around the world. And most major cities now have some form of Map Time meetup. Ours, Map Time Davis, has a little bit of more of a research flavor, more of a university type flavor, just because of the nature of our city and also our sponsors. So, we tend to be a little bit more on the researchy side of things, but we still like to meet up and have fun and do some less researchy things sometimes. So right now our format is we alternate weeks with a workshop and then something that we call studio. So today is a workshop. It's a more formal learning adventure where we have materials prepared and sort of a step-by-step kind of process we're going to work you through, and it's a more formal learning situation. Next week we'll have a studio, which is less formal. It's a group of people that meet up to talk about a certain topic, and so next week we're going to follow along with what we do this week. We're going to talk more about working with address data, talk about more options, probably talk about PostGIS and things like that. And related tools. So you're welcome to join us. You can find our information about how to register for that on the UC Davis Data Lab website, datalab.ucdavis.edu. So this is sponsored by Data Lab, and it's also a part of Data Lab's Spatial Sciences Research and Learning Cluster. So that's a community that Data Lab helps to support, and it's specifically around spatial sciences. So our main product with that particular group is Map Time Davis. I'll tell you a little bit more about how to get more involved with that in a minute. So what is Data Lab? Data Lab is a unit on campus at UC Davis that is funded by the provost and also supported by the UC Davis Library. So we're housed within the library. We have a lot of crossover with library events and staff and things like that. So, that's where we live in theory. Of course, right now we're all working from home, so welcome to my living room. What we do for the research community is we facilitate the application of data science methods, technologies, and best practices with the goal of enhancing research and learning in all domains across the university. So we work with everybody. Like, you wouldn't believe the range of folks in domains and things like that that we work with, all the way from like computer science to art, across the board, we work with pretty much everyone on campus. And in terms of services, we offer things like office hours. So every week on Monday afternoons, the whole staff pretty much sits in a Zoom room and waits for people to come ask us questions. It's usually pretty busy. We also offer project support and training, such as today's workshop, and also community like the Spatial Sciences Research and Learning Cluster. But there's also other communities, like we actually sponsor through our research and learning clusters, the Davis R Users Group. They're a part of Data Lab now. We help support that. We also have groups on things like Python and natural language processing, text analysis type stuff. We had a Bayesian stats group at one point. So anyway, we have a lot of communities. If you're interested in joining from the UC Davis community, come check out our website, or you can send me an email and I can help direct you with that. So how do you get involved in things like the Spatial Sciences Research and Learning Cluster and Map Time? So you're already here and you're already participating, which is great. So come to more workshops and studios. Help us plan. You can become a helper at a workshop like our 3 helpers today, or you can present a workshop, or you can facilitate a studio discussion. Generally, the best plan if you want to get more involved is come to more workshops and studios and get in contact with people like me who can help direct, if you're interested in presenting or getting more involved with helping us find speakers and presenters and things like that. Upcoming events. We've got a couple more things this quarter. We have, like I mentioned before, next week, we're going to be having a studio discussion session about working with address data. So if you've got more questions after today, you can come join us. Or if you want to talk about other tools besides the ones we're going to focus on today, next week is a good time to meet up and chat. After that, the following week, February 23rd, we have some folks from Esri coming to talk about their new field maps tool that's going to be replacing some of their data collection, their in-field data collection tools. So cutting edge stuff, so you can come and learn about that. And then the following week after that, we'll have a general discussion with another studio session about generally field data collection and prepping for field work. So come and check that out. All right. In the interest of time, we are going to switch over to some workshop logistics. So we're going to get a little bit acquainted with our Zoom platform and some of the expectations for today. So please keep your video and audio off. There may be situations where you do need to turn them back on, but for the vast majority of you, please leave it off because like I mentioned earlier, it's going to help with bandwidth issues and also with background noise and things like that. So what I want you to do is if you have questions or comments or things like that, I want you to use the chat window in Zoom, and we'll look at that in a second. And please don't direct message me because I'm going to be teaching and I'm probably not going to see it. I'm going to assume that our helpers are going to be checking the chat. So please message, just put your messages in the chat, make them public, and people will help you as best they can. Also, be kind to yourself. Learning with Zoom is challenging. It's not as smooth as what we're used to learning in person. Obviously, like doing this on Zoom gives us the opportunity to bring in a lot more people and reach a lot more people all at once because we're not, limited by, room capacity. But, it is a challenging thing to do. And if you're working with only one screen, that can also be, it can just add to the frustration. So be kind to yourself. Try, try your best to be patient. But also know that it's okay to just watch. Like you don't necessarily need to follow along. If you find that this is too much to try to do all of it, just go ahead and watch. We'll be posting this video later and all the workshop materials are already online and will remain online. So don't worry about it. If you find yourself falling behind and it just becomes better to just kick back and watch that and learn that way, that's perfectly acceptable. There's not going to be any quiz. You don't have to turn in any homework or anything like that. So just be patient and take some deep breaths because we're going to move a little quickly today, I think. Oh, slide advancing is challenging today. Okay, so chat window practice. What I want you to do is open up your chat. If you look at your Zoom screen, for those of you who are less familiar with Zoom, Down at the bottom, you're going to see a little ribbon that has buttons and icons on it. There should be one that says chat, and you can open that up and you will see a place to type messages. So what I'd like to have you do right now, just to give it a little practice, is go ahead and introduce yourself in the chat. So tell us your name, your affiliation, your position, anything that you're comfortable sharing. So for example, if I'm going to be posting mine, I would tell you that my name is Michele Tobias. I'm from UC Davis Data Lab. I'm staff, and then my position, just to give you guys an idea of who I am. So go ahead and open up your chat window and go ahead and type in your introduction and post that for everyone to take a look at. Great, I see people posting. Thank you. We'll give you guys a minute or two to do that. Again, if you're less familiar with Zoom, you're going to look at the very bottom of your screen. There will be some icons at the bottom. You want to click on the one that says chat to open up the chat, and then introduce yourself in the chat box. So one reason that I'm doing this, even though I know a lot of us are very familiar with Zoom at this point, I know that other institutions and groups have picked other platforms. So you may use similar tools in your daily life, but if you're not familiar with Zoom specifically, sometimes it's nice to find out what I'm expecting you to be able to see. I know every time that I get on a different platform, I'm a little lost. So make sure everyone is familiar with the tools and give you a chance to make sure you're comfortable today. I'm appreciating seeing all your names scroll past and seeing all of the various places that you're from. Seeing some familiar names and then some folks who are from very far away from where I am. So it's very exciting to have everybody here. I appreciate you taking the time to introduce yourselves and get familiar with the platform. So I'm going to go ahead and move on, but feel free, if you haven't posted your intro in the chat window, go ahead and do that still. There's no time limit on that. All right, so the other thing we're going to be working with today is the participant tools. This is moved around depending on your version of Zoom. So if you can't find it, just keep poking around until you do. Right now, in my version of Zoom, at the bottom of my screen, where just kind of near where you saw your the place to open up your chat, there is a icon that says participants. And if you click on that, you have some reaction options. If I click on mine, it's not going to actually show it to you guys because of the way Zoom's set up. But down at the bottom, you'll see participants. And if you click on it, you'll see reactions in there, some options to pick. I'm going to use this to find out, pacing and things like that during the workshop. Depending on how things are going, I may use it more or less. But what I'd like you to do right now is go ahead and answer this question for me. So, do you have previous experience with QGIS as a tool? If you do, click the green yes button, and if you don't, click the red no button. And also, I will note, being a cartographer, I'm not thrilled with the red versus green option. So the yes is a check mark, and the no is an X. So if those button colors are similar to you and you can't tell the difference, look for the check for yes and the X for no. So you're answering the question right now. Do you have previous experience with QGIS? And I can see that Zoom has changed. So it's flashing very quickly, whether you say yes or no, it's not leaving it up for me. So that's fun. But so I'm seeing kind of a mix. It looks like we're probably about half and half right now, which is great. I'm going to assume that okay, we're done with slideshow. I'm going to assume today that you have some experience with GIS, but not necessarily QGIS specifically. All right, so. Okay, so I appreciate you all hanging in there with the intro stuff and getting used to the platform. What I want to do right now is jump into the workshop materials and get going. So take a little stretch break here, and crack your knuckles, get ready to go, because we're going to start with the materials momentarily. So I'm just going to copy some links to put into the chat window. So what I've just posted into the chat is the link to the workshop materials. So you can open that up in a web browser if you'd like to follow along with what I am going to be showing on the screen and referring to as we go along. You don't need to have it open. You can just follow along and I'll tell you what's on the page. But for those of you who like to have it open and follow along step by step, that can be helpful. Let's see. All right, so I think we are ready to go. Let me make this a little bigger just because it might be hard to see. Here we go. Okay, so hopefully that's at least somewhat readable. And again, you can follow along with the link that I just put in the chat. Okay, so geocoding. Again, welcome. I'm glad you guys are here. Looks like we've got a really good group today, and we are ready to get going. So in this workshop, the plan is that we're going to talk about concepts and skills needed for geocoding address data. We are going to also look specifically at how to work with data that needs different security concerns. So in particular, personally identifiable data, or PII data, is what we're going to focus on, because it is the most complicated thing to deal with, and it's a lot easier to get more relaxed. So when I've got data that is publicly available, I have less concerns. It's a lot easier to work with. So I'd rather start with the more specific type of data so that you know what the hardest thing to do is, and then you can always get, work with easier data later. It's better than trying to get more complicated later. So all right, so the plan is to get you a conceptual understanding of how geocoding works. We're going to work with different options for geocoding data. We'll talk about different tools that you can use, and then we're going to get experience with geocoding with a very specific tool. We're going to work with QGIS and the QGIS plugin, which is a good tool. I'll talk about some of the reasons why you would use it versus other things, and all of that. So the prerequisites I mentioned earlier is I'm going to assume you have a basic understanding of GIS concepts. I'm going to assume that you've probably also worked with a GIS in general. So if you have experience with like ArcGIS or things like that, I'm going to make that assumption. I think if you don't have experience with any of that, you'll be able to follow along just fine, because we're working with a graphical tool. But if you do need more experience later, feel free to look at the Data Lab YouTube channel. We've got some really good recorded workshops, or send me an email. I can help direct you to some introductory materials that would be helpful too. Okay, so software today, we're going to be working with QGIS version 3.16. If you are working with 3.14, you're probably going to be fine. Don't worry about it. Even 3.12 is probably fine. If you're working on a much older version, you might want to just sit back and watch and then upgrade and then try stuff on your own later. I wouldn't recommend trying to do Zoom and upgrading QGIS at the same time. The other things you're going to need access to are a spreadsheet program of your choice, such as Excel or LibreOffice Calc, or you could even do this in Google Sheets. That would be fine. And then the other thing you're going to need is a text editor with line numbers, so not a word processor. So things like Windows comes with this program called Notepad, but it doesn't have line numbers. So I'm going to suggest using Notepad++. It's a pretty handy notepad. And there's other, for other platforms, there's other tools that have line numbers specifically, and it'll be apparent why later. If you don't have it, we can work around it. It'll just be easier if you can actually see the line numbers. Okay, so deep breath. That is sort of the learning objectives and how we're going to work with stuff. I think we're ready now to jump into concepts. So you're here for geocoding, but what the heck is geocoding? So geocoding is this process where we take address data, like postal addresses that you would put on a piece of mail to send through the mail system to get to an address. We're going to take those postal addresses and we're going to turn them into real world location information. Typically, we think of latitude and longitude, but it could be, other coordinate systems as well. But how does this work? Because when we have a postal address, it's not really the same thing as like lat long, where lat long is a grid system, and if no matter what, number you give me, I can go find that place in the world. An address is really a human construct. It's not, doesn't exist everywhere. It's not super systematic. It's not like a grid. So how do we turn these into something that has, sort of more exchangeable location information? Okay, so the reason that this works is because we do have something of a system with postal addresses. Typically, a postal address has uh, sort of more increasingly broad information on it. So like, for example, down here, I have the example of UC or City of Davis's City Hall. So the address for City Hall is 23 Russell Boulevard. So that's a house number, a property number, a street. So more increasingly vague information, the city, then the state, and then postal code really doesn't fit in this because postal code is, the zip code is actually a route. It's actually a linear system. We like to think of them as polygons, but they're not. So kind of, that's sort of the exception to my rule here. And then the country USA. So it's getting more and more broad with the information that we list, with the exception of this postal code. And then the same thing, like if we look at the address for City Hall in Sydney, Australia, we have a similar situation, right? We've got house number, we've got street number, we've got the city, the state, their postal code, and the country itself. So we have this sort of standard format for addresses that we use in most of the world, which is helpful. And this actually helps our system of geocoding. So the fact that we can expect addresses to be written a certain way and formatted in a certain way, we can use to our advantage in this process of turning the addresses into something that is more universal, like a lat long. Okay, so the other thing is that with our streets, we typically, I say typically because this isn't always the case, but we typically arrange our buildings along streets in a specific way. So you may have noticed if you're driving down the street, you have, for example, like this is the 100 block of Oak Avenue in our diagram here. So every address on this section of Oak Avenue between the two cross streets is some version of, it starts with a 1, it has 3 digits. So we call it the 100 block. So this range here, the address range on this block is from the address 100 through, in theory, 199, but it actually looks like in practice it goes up to 113. The next block, if we keep going down the street, will be the 200 block, where all the addresses will start with a number 2, and so on. So the way that we organize streets is also helpful in that all of the addresses are related to each other. The other thing is that typically in most places, they arrange the addresses so that all of the even numbers are on one side of the street and all of the odd numbers are on the other side of the street. That again is not always the case, but we can sometimes make this assumption to help us with the geocoding process and estimating where things are. So for example, if I'm going to Oak Avenue for some reason, and let's say my address is 110, and I've never maybe been to this place, but I'm sort of familiar with Oak Avenue. So I'm driving down Oak and I'm going to think like, wow, okay, I'm looking at the addresses and I'm like, okay, this is, the 100 building. And I know that it's 110. So I'm going to keep going and know that that's further down the street. If I know that the range on this street is only from 100 to 113, I'm going to assume that 110 is kind of near the end. But if I'm assuming that my address range is from 100 to 199, I'm going to assume 110 is closer to address 100. So depending on the assumptions we make, where we estimate our address along that road is going to change. So keep that in mind. When we're doing geocoding, we are making an estimation of where we expect the address to be, given the assumptions that we make and the data that we have about our road network. So it's not a precise location. So if we do geocoding, we need to know that the location that we put any given address at is not necessarily where it actually is. We're not doing parcel matching where we have polygons related to specific parcels that have attribute information such as the address, that would be actually a different process. That's more along the lines of a database join, where we'd be matching things up that way. So geocoding is an estimation process, and it's not always, in fact, I would say it's never exactly where the address is. So just keep that in mind. We're making a guess. So here's also an example of what the data looks like sort of under the hood, what the table looks like for this block of Oak Avenue. So we have a from address, so the start number, and then the end number for the two sides of the street. And that's going to help with, matching where any given address is along that road. And we'll see this again later when we get into actual data. Okay, so this process, so we've talked about how addresses work and why we can make some assumptions and make a system that works for matching addresses. But what does this geoprocessing or geocoding process look like under the hood? So we're going to go through 3 steps today. We're going to start with our input data, and that data almost always needs cleaning. So, and formatting. So we get addresses, maybe it's input, like what comes to mind, I've been working with some medical data recently where you ask a patient when they check in to give you their address, and they may type in their address in various ways. They're all valid addresses, but we need to clean that up. We maybe need to break some things apart depending on what our geocoder wants. We may need to work with some of the formatting, or I'll tell you this many times, get rid of the suite numbers and apartment numbers and things like that. Valid addresses for the Postal Service, but not for the geocoder. So we have to do some cleaning on our part. Once we get our data cleaned up, we're going to pass it through the geocoder. And inside this geocoder, I like to think of it as like, a machine I'm sending it through. So inside the geocoding software, it's doing a couple things. One thing it's going to do is going to process your addresses again. It's going to do a process called normalizing. So you'll have an address normalizer, and that takes your address and it does some more cleaning to it, some standardizing. Typically it'll do things like change all of the, if you have like the word street, it will either make all of the STs abbreviated, or it will decide, oh, our standard format for this geocoder is to spell it all the way out. So it'll say street for everything. So you give it valid addresses and it kind of fixes them the way it needs it. The other thing it's going to do is bring in the road network data, either that we give it, or if we're working with a third-party geocoder, that stuff's already inside the geocoder. So it's going to take that road network information and it's going to start matching addresses and estimating the position. So those are the 2 things that happen inside the geocoder, a little bit more processing and then address matching with the road network. So once that happens, we get our results back, and we're not done yet, because as with all data processing and analysis, we need to make sure that the data that we get back is good. So we need to assess the quality. If it's lower quality data, we can actually take a look at it, refine it, and then send it back through the geocoder if we think we can fix it. Like maybe we accidentally left some suite numbers or apartment numbers in our address, and we'll take those out and fix them and then run it back through. If it's high quality data, we like it, we can keep it, we're ready to go and work with it further in another process. So those are the 3 main steps we're going to go through. This process of preparing the data, geocoding it, and then assessing the quality of it and potentially fixing and rerunning it. So just like science, we're going to run through the process until we make an assessment that we like. Do we have any questions about that process so far? I'll leave up the diagram because pictures are nice. So I'm looking at the chat. I don't see any questions. I'm seeing people hit the no button. That's helpful. So if you've got any questions, feel free to type them into the chat, and then the helpers will, if there's something that they think I need to address, they'll stop me and say, hey, Michelle, answer this question. Okay, so I'm seeing a question pop up about, do different geocoders have varying quality in their performance? Yes, definitely. And we're going to talk about that next a little bit. So that's a good segue. All right, so I'm going to go ahead and then move on, since that's such a good segue. So we're going to talk about software. So that middle part, the second step that we talked about, the geocoder part, there's a lot of considerations to look at. And this is one of the reasons geocoding can be so complicated. It's just, what geocoder are you picking? And how does all of this work? So some things to consider when you're looking at a geocoder is budget. There are a lot of great tools out there that do geocoding, and a lot of them cost money. So if you're planning on doing some research that requires geocoding, you might want to think about when you put in your grant proposal, how much money are you going to need to get the results that you want? There are a lot of good free geocoders, but the complexity of the data that you use in the road network component of this is a lot better when you're paying for tools that someone has taken the time to actually build up that data set. So you'll see with what we're going to do today, it's doable, it's workable, but it's not the best result. So you want to think about budget. You do have a ton of things that you need to geocode. How much work do you want to put in by hand versus using a service that's going to do it for you? How much data is required? Does the software that you're going to use, like the one we're going to use today, where we have to go find our own road network, it's not provided in the service. So is the data available? How much data do we need to process? How spread out is it? Like the tool we're going to use today is great for really local geocoding. I wouldn't use it for like the entire country. It just isn't built for that. Also, geographic restrictions. So for example, I really like Geocodio as a platform. If I have data that I don't need to keep private, I like to use that because it works really well, but it's only really good for the US. They don't have data for the rest of the world, which is reasonable. They've got a really good data set for the US, but it's not really built out right now for international things, although that may have changed. I haven't looked at it in a few months. So I want to make sure that I'm using a geocoder that is built for the area that I'm working with. Also, you want to consider your platform. So what tools do you need to use? Is this a tool? It may be the best geocoder in the world, but if it needs to run in Python and you don't know how to work with Python, you'll either need to learn how to work with that or find a tool that works with the skills that you've got. It's always a balancing act between what do you want to learn, how much time do you have, what's your skill set, or can you find someone to help you with it? So think about that, like, what is the platform for the tool that you want to use? The tool we're going to use today runs with QGIS, which is a graphical platform, which is nice because it doesn't require any coding skills. So that is good for this kind of workshop where we have people from a wide range of skill sets. And then also another important thing to consider is local processing versus third-party processing. This is really important with PII data or HIPAA data that needs to be kept private. So if I have data that is personally identifiable or falls under HIPAA, I want to make sure that all the processing that I do happens on my local computer or on a server that is secured. What I don't want to do is take people's personal information and send it to someplace like Google or Geocodio or, basically send it over the internet unsecured so that anyone could see it. That's a really good way to end up as a headline in the newspaper, and we don't want to do that. So we want to make sure if we are working with this kind of data that needs to be kept private, that we are not sending it to a third party unless that third party has like a secure server and we know that it's approved for what we're working on. So I've got a list of software options on here. It's a little hard to see with it zoomed in, but there's two sections. One is local geocoders, and that's what we're going to be working with today, specifically this QGIS plugin, where everything's going to be processed on our local computer. Other options, if you need to work with bigger data sets, I would recommend this PostGIS Tiger geocoder option. I've got links to how to build that. This is my personal blog, so if you see something that needs updating, I know that the instructions are for an older version of PostGIS, but it tends to work pretty well. Anyway, that's better for larger data sets because I can load a larger road network and work with multiple counties worth of data easily, but it does require SQL programming. Same thing with working with open address data in PostGIS. I've got another link to how to work with that. But again, that does require, because it's PostGIS, you're going to be working with SQL, which is not insurmountable, but it just depends on what you're planning and how much time you've got. The other thing is you can work with this geocoder called Peleus that is installed. You can install it locally, and that's another good option. But as you can see, the the more complex and the larger data sets you get, the more tech skills you're going to tend to need to be able to work with that. Third-party geocoders, again, most of these are ones where if you're working with PII data, you don't necessarily want to be using. You want to make sure that you're looking at their terms of service and how they process data to make sure that it's safe. The one exception to this list is Geocodio does have a HIPAA compliant geocoder, and there are other similar companies out there that may also have this option. The caveat to this is, okay, so it's really easy to use. You just upload your data to their website and then they process it and they email you when it's done. It's great. It's easy. They've got really good results, but it is expensive. So you want to budget for that. The free Geocodio service that's not HIPAA compliant is good for public data. But again, you only get so many free lookups per day. So you want to budget for that. Do you need to pay for it? Do you need to break up your data set and run it, plan for a week of, every morning you run your 2,500 lookups or whatever. And again, there's other options too, with varying degrees of tech necessity. You can also use ArcGIS. If you are a UC Davis affiliate and you are planning on geocoding, please contact Esri support before you get started to talk about the credits needed. It is possible to do, but you just want to make sure that we get enough credits assigned to your account before you get started. So it's better to contact them ahead of time and not have surprises. If you're on another UC campus, I recommend chatting with whoever is your Esri license administrator to talk about the credit situation with that. So it's not necessarily free. It does require these things called credits if you're using ArcGIS. But we're going to be using QGIS today, so you don't need to worry about that. The other thing I should mention, because I think it was Lily asked a question about the quality of these, there are definitely varying qualities of the results you get. So things like companies like Geocodio that have a really built out robust road network data set. They're also working with parcels sometimes, so they can locate your address based on the parcel boundary. Those are going to have much better results than, for example, what we're going to be working with today with the QGIS plugin. We're only going to give it, one set of data to look at, which is the road network from the census. And it's going to be estimating, and the estimates it's going to have are not going to be as good as something that has a really robust road network with really good so the thing with Geocodio is they have multiple options for different things that they're going to match with. So if you need super accurate results, you want to budget for things like services that have these bigger data sets. If it doesn't need to be that exact, then other things like using the tool we're going to use today or use the PostGIS-Tiger geocoder should be sufficient. I would not use address geocoding for anything that needs to be super precise. So if you're, for example, delivering important medicines with a drone and it needs to get into the hands of one specific person, this is not the process to use to identify that. You definitely have varying degrees of wiggle room on your data sets, and geocoding generally works better in places that are more populated because we have better data for that. So if you're geocoding in rural areas, you're also likely to have less quality just because of the lack of information that we have. So these are things to keep in mind. All right, helpers, are there any questions that I need to answer that you think I should talk about?
Largely looking good.
Okay, sounds good. All right, so we are going to now jump into the hands-on portion of this. I've been talking a lot. I'm going to continue talking, but you're going to get to do stuff now, so that is exciting. So one thing we're going to talk about is the first step in our process we talked earlier is the cleaning part of this. We need to prepare our data in a way that our geocoder is going to like so that it can read the data. Most importantly, we need to check and see what format our geocoder wants. So typically we want columns for things like street address. We might need to separate out by number and street name into separate columns. We might need them together. It depends on the geocoder. Columns for city, state, postal code, country, that's all pretty typical. Things that we should not include though, Geocoders really hate apartment numbers and suite numbers and half addresses. So if I live at 49 and a half A Street, it does not care about that half. It just cares that it's the number 49 A Street. So we want to get rid of those. We can move that into another column so we can keep the data, but we need to get it separated so the geocoder doesn't look at it. And the reason that it doesn't like these suite numbers is because if we have, for example, 150 Main Street Suite A, it literally thinks that the street number, or the street name is Main Street Suite A. It doesn't know that the Suite A part is extra information. It thinks that that is all one street name. And then it's going to look and it's not going to find it because there is no Main Street Suite A. There's just Main Street. So we need to not confuse the geocoder with extra information. The other thing is we need our abbreviations to be standard. So we want to have like standard abbreviations like ST for street or BLVD for boulevard or DR for drive are fine. That's standard. The address normalizer knows what that means and it will handle it. What we don't want to do is make up our own shortening. So for example, I had a data set once that had you know, in California in particular, we have a lot of street names with Spanish endings on them, like Paseo. And in this data set, they had abbreviated Paseo as PSO. It's not standard. The address geocoder or the address normalizer doesn't know what that is. So we had to go in and find and replace all of the PSOs with Paseo to fix that. So plan ahead for that. It'll save you a lot of data cleaning if you know ahead of time that you need to use standard abbreviations. Also, don't abbreviate city names. I had a data set where for some reason someone had removed all the vowels from the city names. I don't know why, but we had to go back and I had to manually fix all of those. So don't do stuff like that. If you plan ahead, then you'll end up with less cleaning to do. The other thing is all caps is bad. So Main Street spelled this way with uppercase and lowercase to a computer is different than Main Street with all caps. Capital A and lowercase a are two different characters as far as your computer is concerned for the most part. So it will get very confused about this. Main Street with all caps will not match Main Street spelled with camel case here. So just be aware of that. You can fix all of these issues for the most part with, find and replace or with various text editing tools to do it automatically, but it's just going to take more time. So avoid it if you can. So we're going to start by trying this out. I've got a box folder that you can click on if you're in the workshop materials to get the spreadsheet we're going to be working with. So we're going to clean up our data into the way that our geocoder wants it. So QGIS geocoder wants two columns for the street number and the street name. So we need to separate that out. So if we look at our data set, we can see our street already has some issues, right? Like our geocoder wants this column to be two separate things. You may also notice that we have the thing I've been harping on, which is suite numbers. So we've got two different formats here. So we need to make sure we clean those up. What I'm going to do is I'm going to bring over my, File Explorer, and I've downloaded my CSV. So I'm going to go ahead and open that up. See if Excel will just open it. It did, but it put it on the other screen. So let me bring that over so you can see it. I'm going to make these bigger so you can actually see what I'm doing. Okay, so first thing we need to do is clean up our data set. So I've opened up our restaurant addresses.csv I chose Excel, but again, you can use whichever spreadsheet program you like. You could even do this in a text editor if you don't mind trying to keep all that straight. But so what I need to do is fix up my columns, right? So I need to separate out my street. You can do this in any way you want. I'm just going to make a new column. Insert column. I'm going to call this, sorry, I'm going to get my, too many windows. Pardon me while I'm moving things around. Okay. So I'm going to call this, I'm just going to put number here so I know what column that is, and I'm going to have street. And all I'm going to do is I'm just going to copy and paste them over. If I had a lot of these, I'd make a formula. I'll have to trailing. or leading space. So I'm just going to edit my data and fix this up the way that it needs to be. And this is why I only gave you 5 addresses, is so that we're not going to spend all day doing this. Obviously, if I'm going to be working with a really large data set, like more than 5 of these, I'm either going to write a script in R to do the cleaning for me, or I'm going to, make a formula in Excel to make these. All right, so I've got my number and my street separated, but again, we also have these suite numbers, and I'm just going to delete these for now, just for workshop purposes. If this was research data, I would separate that out into another column, but for speeding purposes, I'm just going to leave that as is. Oops. Now, what I want to do is I'm going to do a save as, because we're going to show good data management practices. So I'm going to keep my regular addresses, the input data that I started with, and I'm just going to add cleaned to the end of the file name. So I know I've got my original restaurant addresses, and then I've got my cleaned ones in the same folder. So I'm going to go ahead and save that. Yes, I want to keep using that format Excel. Okay, so I've got my data cleaned up now. So I've got a column for the restaurant name, which the geocoder doesn't care about, but for sanity purposes, I want to know which one is which. I've got my street number, or my address number here in the number column. I've got my street separated out because that's how our plugin wants it. I've got a column for city, state, and zip code. So I think this looks pretty good. Again, this gets more complicated when we're working with, like, say 2,000 addresses. It gets harder to clean. So you have to have a pretty sharp eye, but that's why I only gave you a few addresses, so we can make sure we know the whole data set. All right, so I'm going to go ahead and close that. I already saved it, so I'm not going to keep it that way. All right, so back to our workshop materials. Okay, so we did our cleaning process, and hopefully this data will work. This can always be iterated on, so if we found we made a mistake, we can always rerun it. So the next part that we need, so we've just cleaned our addresses. So we did step 1, right, of our 3-step process. Now for step 2 in the geocoding, we need to provide our road network. This is the geocoder we're going to use, doesn't come with a road network already connected. So we need to find the one we want and load that up into our GIS in a minute. So we are going to be working with Yolo County because our data is in Davis. So Yolo County is the county that Davis is in. So what we want to do is go find the road network data from the US Census. Really handy data set for working with things in the US. It's already there and ready to go. The trick is that the US Census uses what's called a FIPS code to identify geographic entities like states and counties. So we can go and we can actually look up what the FIPS code is for our county at this handy locator. So we can scroll, or we can do a find for this for YOLO. Fortunately, I don't think there's any other YOLO counties in the US, which is handy, but we've already found it for you. So the FIPS code for Yolo County is 06, which is actually the code for California. Anything that starts with 06 is California. And then the county part of this is 113, which actually makes me happy because the 113, the highway 113 runs basically straight through Yolo County. So I don't know if this was intentional, but I think it's pretty cool that 06 is California and then 113 is the highway that's unique to Yolo County. So that helps me remember it too, which is really nice since I live in Yolo County. Okay, so then now that we know that information, we can go to the US Census Bureau's FTP site to download the edges. So I'm going to open this up. And actually, I'm going to pull this off to the side so I can narrate better while I show you what we're doing. Okay, so this is the FTP site for the US Census Bureau. You can think of this as just basically a download site where things are organized, and I don't have a graphical interface. I'm just going to dig through the files like I would on my computer file system. So we're looking for a data set called the edges. So what I want to do, in this case, we're going to be working with the Tiger data from 2018. I can see now that they've updated, they've put up the 2019 and 2020 data, but we're going to work with 2018 because I know that this works. You could try grabbing the newer data if you want and play with that as well, but because I know this is here, So again, I'm looking for the folder called Tiger 2018. And I'm going to click on that. So we're in the Tiger 2018 folder. And now I want to look for the folder called Edges because that's the data set that we need that has the road data. So right here I see we've got Edges, and that is the next thing to click on. So we're going in the Edges folder. And now this is where that the FIPS code comes into play. So what we want to do is we want to look for the file that, okay, everything has TL 2018 at the beginning. What we want to look for is in this third place, we want to look for the 06113 or 6113. So I can keep scrolling down because I can see like we're just in 02. I see 05. Getting close, 06, and I'm looking for 113. That is not it, that has a 0 in the front. Getting close, there we are. Okay, so I'm looking again for, I want the file that's TL 2018 06113. It's kind of not too far down, but there's a lot of files to look for. So what we want to do is click on that. We're going to download it. So you want to put it somewhere where you can find it. I've got workshop data already set up, so I'm going to just, and in the interest of not overloading my bandwidth, I'm not going to download this right now because I already have it, but you should go ahead and grab it and put it somewhere where you can find it. I've put mine in specifically a workshop folder for this workshop. So this is what the result looks like. I get the zip file with our 2018 06113 edges. So when you finish doing that, I want you to go ahead and click the yes button in your participant tools. That way I can know that you are ready to go. But if you're still working on it, go ahead and keep doing that, and we'll hopefully get that done soonish.
Michelle, while people are downloading that,
Yep.
we have a question. What is the difference between the Tiger, GENS, and TGR and other folders that were in the repository?
Oh, that's a good question. So the Tiger data is specifically, I know it sounds funny, but it's that is the spatial data for the US Census. Tiger is actually an acronym that stands for something, but heck if I know what it actually stands for. So when you see Tiger in relation to the census, that's the spatial data. The other folders I'm not familiar with. You could probably do a Google search and find out what that is. Oh, Alex has, I was going to just ask if Alex knows because he's a wealth of random geospatial information. So it looks like there's a README PDF you can take a look at to find out more about those. So topologically integrated geographic encoding and referencing. So it sounds like this is a data set that has some kind of topology relationships in it. So topology is like how things are connected, and it's like data standardization and snapping and things like that. So I don't know specifically about those other two ones, other two data folders that are in there. Alex, do you want to chime in? Do you know more about
I'm
that?
just reading the PDF. Gen Z says that they're cartographic boundaries, and the TGR is a file geodatabase version of the Tiger shape files.
Mm-hmm. Great. Thanks. That's probably helpful to know. So yeah, the census actually is a wealth of geospatial information, which, you know, might sound surprising, but we need all that information to be able to figure out what all of the counts that the census does actually, you know, all of that relates to spatial data. So they have quite a bit of spatial information available. Okay, I'm seeing the yeses slow down. And again, like Zoom is not leaving it up for me like it did like last week. So yay, Zoom updates. But if anyone needs another minute, go ahead and click your no button right now so they can see if we should wait another minute or two. Okay, we've got a couple folks maybe that need another minute. So I'll kind of preview what we're going to be working on while we wait for that download to finish. And actually, why don't I go ahead and while we're waiting, I'm going to go ahead and unzip my folder. So we do need to unzip this data. So if you navigate to where you've saved it, you can go ahead and I have 7-zip, but you can use whatever tool you want. And I'm just going to extract my files here and put them in the same folder. You can put them in a separate folder, however makes the most sense for your personal organization is fine. So when I unzip it, I'm going to get, because we've got a shape file, and shape files come with an entourage, we have all these other files. These need to stay together. If you're unfamiliar with how shape files work, if you were to need to move these, all of these files must stay together. The main star of the show is this .shp file, but it cannot function without the rest of these. So I like to think of it as like, you know, groups of teenagers that travel in packs. They have to stay together or they're not functional. So be careful with shape files. We're kind of moving away from that format in the world of geospatial, but a lot of people are still using them, even though for data management, they are challenging. So just be aware of that. I generally think if I'm unzipping a shapefile, I probably am leaving it where it is, just so that I don't create problems. Without some of these files, you'll lose information like the projection or the database or things like that. So you definitely want to keep all that together if you can. So I want to preview sort of what we're going to do next so that you are aware, and you know, if you're still waiting on your download, you can listen to what I'm going to say and be prepped a little bit. Okay, so what we're going to do is next step, we're going to start working in QGIS. So this is the second part of that geocoder process where we've got our road network and we're going to plug that into our geocoder along with our data that we want to geocode, and then it will pick our addresses or match up our addresses with locations for us. So we're sort of still working on that second part of the 3-step process. So we cleaned our data and we think it's ready to go. And then we're going to put together our geocoder and run our data through it. So that's the next step in QGIS. And then obviously once we get our data back, we'll assess it for how good it is. So in the interest of time, I'm going to go ahead and move on to the QGIS part of this. If you're still waiting on your data to download, like I said, kick back, listen. You can always look up the materials later. They will stay online. The written materials will always be there. And by next week, we'll have the video up on the Data Lab YouTube channel. So don't panic if you're not quite there yet. Just sit back and watch and you'll have a pretty good idea of what we're going to be doing just by watching. Okay, so you're going to open up your QGIS. In Windows, typically what I do is just search for QGIS and open it up from here. On Mac and Linux, you'll use your regular, however your process works for finding and opening your software. So go ahead and open that up. I've already opened mine just because I needed to do some stuff on the back end. So mine looks brand new and doesn't have all the other stuff that I generally work with on a day-to-day basis. If you haven't worked with QGIS before, your interface may look something like this. You may or may not have the news at the top or the templates and things like that, but don't worry about that. So there's a question in the chat I see about OSM. Yes, there are tools that can use OSM, but remember that you want to be careful and make sure that it meets your data security needs. A lot of the tools that use OSM use a third-party geocoder. So just make sure that you're bringing your OSM data into your local environment and not sending it out if you're using PII data. So just a caveat on that. But yes, OpenStreetMap is a potential road network source. Okay, so we've started up QGIS, and then what we want to do is start a new project. So typically what I'll do is I'll just click on this new project button up here at the top, or you can click on the new project here in the middle if that is on your screen or not. So I'm just going to click on this, or you can also click on project and new. So project menu and then the new button. Many, many ways to start a new project in QGIS. Okay, so this doesn't look very exciting. Quick tour for those of you who are new to QGIS. When we have something to look at, your map data is going to show up here in this big blank spot in the middle. All the layers, all the data we're going to load is going to be shown here in this layers panel. For your ArcGIS people, it's also called a table of contents. So you'll see your list of layers here. And then this browser part here just shows up. It is useful for other things, but we're not going to necessarily work with it today. I'm actually going to hover over the middle of this and it has an option to resize it. So I'm going to click and drag and just make it a little smaller just for purposes of showing you what's going on today. Okay, so the first thing that we are going to do now that we have our new project is we are going to load our road network data. So I'm going to use this button here that looks like 3 cards red, yellow, and blue. Your menus may be in slightly different places. The other option we can do is, do layer. So we can go on the layer menu and click data source manager. Either way, you can either click the button or go through the menu process. And we are going to be loading vector data. So I want to click on vector. And our data set, we need to find where it is. So I'm going to click on this 3 dots button, and that's going to open up my browser so I can find my workshop data. So I know I saved mine here, my D drive. Geocoding. So I want to load up, in this case, remember we mentioned that we want the .shp file for our road edges. So I'm looking for this TL 2018-06-113 edges.shp. I don't need to tell it all of the files. It knows if I pick the SHP, it's sort of the leader of the group, it will point to all the things it needs. So I'm just going to pick the .shp file off the list, and I'm going to click open. So I'm not going to worry about the rest of this, all this encoding stuff it will do automatically. So I'm going to go ahead and click add. And it's going to ask me what transformation I want. This is a bigger discussion, but go ahead and pick the first one off the list. It's just asking what geographic transformation I want for my coordinate reference system. Coordinate reference systems are a whole nother workshop, which we can do later. So we'll just gloss over that for now. Okay, so I've got my, you can see underneath the dialog, we've got, looks like Yolo County, which is good. So that's our road network, looks like roads. So we're doing good with that. It looks like I can close this for now. I'm just checking I'm looking at the workshop materials and making sure I didn't forget to add anything. You know what I want to do is I also want to add my address data. We may not need to do this. We probably can pull it into the plugin just itself, but this way we can actually look at it. So I'm going to click on in my data source manager. So where I added my data before, I'm going to click on delimited, which lets me add a delimited file. So like CSV is a comma separated variable or value. So that's delimited because it's delimited with a comma. So I'm going to click on browse, the 3 dots button, and I want to pick my cleaned address data. We could run the other data, but we know it won't work so well because it's got the suite numbers and things like that. So it gives me a quick preview of the data. Looks good. I could mess with any of these other parameters if I needed to, but right now I don't. It's previewing well, so that looks good. Everything's in the columns I expect. So I'm gonna go ahead and white field must be selected. Okay, so it's thinking that, okay, so we do need to change something in the geometry definition. So if I expand this geometry definition section, I need to tell it that there's no geometry. So it's expecting a lat long, a column for latitude and longitude, but we don't have that because we haven't geocoded it yet. So I'm going to click no geometry so it knows it's just a plain table, and then I'm going to click add. And so it doesn't actually, you'll see it doesn't show up on the map because it doesn't have any spatial information, but it puts it in my list of layers, so information that I want to work with. Okay, so that looks good. I'm going to go ahead and close this dialog now because I have the 2 pieces of data I need for my geocoder. I've got my addresses and I've got my road network. So that looks good. So I think that we are ready now to actually put this into our geocoder and geocode some stuff. So we need to load up the software that we want to use. This is a plugin. So QGIS uses this concept of plugins as like add-on. So if you're an ArcGIS user, you're familiar with the idea of adding on different functionality. QGIS has a similar concept. So I see a question in the chat question about how does the road network look in the table? That's a good question. So if we click on our road network in our table of contents and we right click, you get a menu. And if we click on open attribute table, we can actually look at this. So remember we had that preview earlier in the workshop where we looked at the example of Oak Avenue, and then there's the example of the data table. So we've got pieces of information in here, like things that will make sense to us as human people. like full name is helpful. Like this is Pump House Road or Z-Line Road or Clarksburg Road. We had that in the example, we had that from and to addresses. So for example, this section of Z-Line Road, wherever that is in Yolo County, it ranges on the left side from this very large number, 4,800 to, so it goes from 40,000 to 48,698 on the one side. I should have picked an easier one to say, but anyway, you get the idea. So we've got our to and our from on both sides of the street. We saw that before, and other information that is, depending on what you're working with, some of this is useful, but for most of what we're doing today, this is extra, but it does have the information we need. And we'll see that when we load it into the geocoder. Got some zip code information in there. That county FIPS code. So remember, we talked about state is 06 and then the county is 113. So those should all be the same because we just downloaded one county. So that's what that data kind of looks like under the hood. You can poke around at it more. Feel free to explore. You can't hurt anything. If you do hurt it, just re-download a new version of it. It's there and you can always get a clean copy. All right. Okay, so that is what the data looks like. And then if we look at our address data, this should look familiar, right? This is what we just cleaned and what we just made. So we've got restaurant, we've got the number, the street, city, all that stuff. Okay, so we're ready to work with our geocoder, but we need to load the software for it. So this happens with plugins for QGIS. So I'm going to click on the plugins menu up here at the top of my screen. And then I'm going to click on manage and install plugins. So that first option. And that's going to open up my plugin manager. It popped up on my other screen, so you didn't see it load, but bring it over so you can see it. Now, there are a ton of plugins in here. Plugins could be its own workshop itself, so we won't get into too much detail, but we know that we want to use this particular one. So it's called QGIS. And as I start typing, it starts filtering. So I can search in the search box. So I'm going to click on QGIS and see, like, I can read about it and make sure that it's the right plugin I want. So it tells me it's a QGIS vector layer. It works on vector layers. It's Python plugin. That's pretty normal. Most of them are. And it talks about that it does geocoding. And also this plugin actually has a lot of other capabilities, which is kind of fun to play with. Just FYI, the reason it's called QGIS is because the author's name is Michael Min. So he named it after himself. So if you're wondering why it has this funny name, that is why. I will tell you, it's hard to know what to name your plugins. So I'm going to, now that I know that this is the one I want, I'm sure of it, I'm going to click install plugin. And it's going to install it in my file system for me, and it should be ready to go. So everything looks good. I didn't get any warning messages. So I'm going to go ahead and click close on my plugin manager. And now you can see up here at the top of my screen, I have this new toolbar called QGIS. Some plugins will install into other menus, but this one has its own. So what I want to do is, you can see it does all kinds of cool stuff, but I care about geocoding today. And I want to make sure that I pick geocode from street layer. This is the tool that loads things and does everything locally. I could use the web service version where I can load in other road networks, like I'm pretty sure it works with OSM and other things. But again, that I'm concerned about privacy. So I want to make sure that I geocode from street layer because I know this one works on my own computer and I'm not sending addresses somewhere else. Now, obviously the data set I gave you is public information because it wouldn't make sense to share PII data in a workshop situation. So there's sort of a disconnect there, but there you go. Okay, so once we start up our geocoder tool, it's a graphical interface and we just have to fill in the boxes. So it wants our input CSV. So that's our addresses. So I'm going to click on my browser button, the 3 dots over here on the side, and I want to pick my cleaned addresses off my list. So navigate to where you saved your workshop stuff and pick your cleaned addresses table. And I'm going to click open. So this tool needs a CSV. It can't work on other things, but different tools will have different input requirements. Now, the next thing underneath this is I have to answer some questions for it so it knows what to look for. In particular, it needs to know, okay, so what column in my data set has the numbers in it? This tool, if you name your columns well, it's pretty good at guessing. So it's guessing that I want my number column for the street number. So it was good that I named it that. The street name is called street, so it figured that out. The zip code is called zip. So that's all good. It guessed correctly, but if I needed to change it, like for example, I maybe called it something funny, or I just, for whatever reason, know that I accidentally called it the state column, I could switch it. But in this case, we know it's zip. Now it wants to know what my street layer is. And it guessed because it's the only spatial layer, but if I had multiple things loaded, if I click on this drop-down menu, it'll have the list of all of my things I can pick from. But because we only have one thing that's spatial, it's the only option. Again, underneath this, we have to tell it some information in order to work correctly. So it needs to know what is the street name attribute. So I actually have notes in the workshop materials about what to pick for these, but I think that it does a really good job of guessing which one it should be. So again, this is why it was good that the whoever asked the question about what is the address table or what does the edges table look like, it's good to take a look and see what how your data set's structured so you can make these guesses. So this all looks good to me with previous knowledge of this data set. So again, we've got our from and tos here, just like we looked at earlier for the right side and the left side of the street. We've got our zip code information for the right and the left. The census data is very well structured for this process. Like the intent of this edges data set is for geocoding. So it's already set up. It has the columns that we need, which is really nice. The last thing I need to do, oh, there's also this option here for setback. So if I know, for example, that I want to make the assumption that all of the houses are set back from the street a certain amount, we can tell it to go ahead and do that setback. Otherwise, it'll just put it pretty much right on the line. For our purposes, it doesn't matter. So we'll leave that as 0, but you can play with it and see what happens. So the last thing we need to do is tell it where to save things. It's always tempting to save things or to use temp files, but I'm going to tell you right now, it's only heartache. Don't do it. Always pick a place to save it. I don't want to save things here. I want to click on my browser button, the 3 dots at the end of that, and I want to tell it where to put it. It's offering where it thought it should go. I'm going to tell it to go put it with my workshop data. So I'm going to put it in my geocoding folder. In particular, this is my output data. So I'm going to call this, I'm looking at the notes to see what I told you to call it in the workshop. I did not tell you, I just said make up something that makes sense, which is fine. So we're going to name it something that we will remember. So I'm going to call it geocoded addresses. So I know what that is. If I was working on a particular project, I'd give this a name that made more sense for the project, but this will do for now. So in our table of contents, this will be named in a way that makes sense. Okay, so that's our geocoded addresses. And then the last thing is that if something doesn't work, if it can't find the address, it wants to put it in a table. So I want to have a table to put things somewhere where I can see what didn't work. This is going to help for proofing. So that last step of quality assessment. So again, I'm going to tell it where to put it. I'm going to put it in my workshop data. So I'm going to call it, in this case, I'm going to call it addresses. And I'm going to leave the not found on the end, but I like underscores, so I'm going to fix that. So now I know when it shows up in my table of contents, it'll call it addresses not found. And then I will know what that means. You can, again, you can name these anything you want. I highly recommend naming things in a way that makes sense to you so that future self in a week or two, when you come back to this, will thank you because you've named it in a way that future self will remember. Okay, so we've got this all filled out. I think this looks good. I'm going to go ahead and it says that it is ready. So I'm going to click, on this case, I'm going to click apply. My temptation was to click close because of the position of the button, but we want to click apply. Okay, so it's telling me my progress. It found 3 of 5 of them, which is not great, but that's all right. It's why we're doing the workshop, so that we can see how this works. Okay, I can see it popped up some points on my map. It's telling me it got 3 of 5, so I'm going to go check out my not matched ones. I'm going to go ahead and click close on this. Okay, so I've got my geocoded addresses. I'm going to open up the attribute table and see what it did. All right, so one of my first things, so we just did step 2, right? This is our geocoding. We took our data, we ran it through the geocoder. So now we've entered step 3, where we're going to assess the quality of it. Now we're going to take a look at this, and we're also going to need, so this is the geocoded addresses. What I also want to do is I want to click on the add data button, and I want to go find my addresses not found data. So that's a CSV. So I'm going to load that with the delimited file section. Find it, click OK. This looks good. No geometry. We learned that earlier. So I'm going to click add and close. So then I can take a look at my addresses not found. Getting kitty help. Okay, so it looks like it couldn't find these 2 addresses. I'm taking a look at these ones, and I don't see a reason why, but we can play with that a little later. What's more concerning to me is that our geocoded addresses, we know these are all in Davis, right? So all of my city information is Davis. If you're familiar with this area, you know this polygon, or this little cluster here of roads, is Davis. Why are things ending up in Woodland and West Sacramento? So that is concerning, right? Our quality of our geocoding is not great. Actually, when I was developing this workshop, I was like, this is really strange. And I went to the GitHub repository for this workshop and was like, what's going on? There's a problem with the plugin. And the answer is this plugin actually ignores the zip codes. So these 3 cities all have different zip codes to them. But also one of the challenges is that Woodland, Davis, and West Sacramento all have a numbered lettered grid system. So it found, in this case, let's see, which guy is this? So this is the first address here is on 3rd Street. There is a 403 3rd Street in West Sacramento, or at least there's a 400 block of 3rd Street in West Sac. So it found that first and said, looks good, I'm going to put it there. Same thing with this one on 3rd Street. In Davis, it put it on 3rd Street in Woodland because it found it first, because it's not looking at the zip codes. So we're going to go and we're going to fix that. And we're going to rerun our data and see what the issue is, why that is happening. So I'm going to just tell it to stop selecting things for me. And I see in the chat that people are speculating about what happened with our not geocoded. So somebody's saying, okay, it didn't work because I was silly and I left in my street numbers for some reason. So let's go ahead and fix that. This is normal with geocoding. Like, I think I've got my data right, and the addresses that don't geocode are, for whatever reason, I can go back and find things that are wrong. So this was a total mistake, but it's a good learning situation. So we're going to go back and take a look at this street number, and we're going to fix it. So what I want to do is I'm going to remove this from my table of contents. So I'm taking out my restaurant address is cleaned. I'm just going to remove that because I don't want, sorry, not open the address table. I'm going to remove that because I don't want that in there. I'm going to come back here. I am going to find my clean data. I'm just going to open this back up in Excel. You probably did a better job with yours and you probably don't need to do this. So I'm going to come in here and I managed to copy, but not remove. I probably meant to click to cut, and I did copy instead. Okay, so now this looks better. I bet these will geocode now. Yes, keep using that format Excel. Okay, so we'll fix that, and those will probably work better in the second round, but that does not change the fact that I knew that these were all going to geocode to the wrong city. Okay, so here's the deal. With open source tools like this, we don't just throw up our hands and say, oh man, it didn't work, moving on. This tool that we're using is the best option for doing small data sets and locally geocoding. So we don't throw up our hands. We don't say, oh, well, we fix it. So I looked at the GitHub repository for this particular tool and looked at the issues and said, okay, there's somebody posted about this. And the answer is actually pretty easy to fix. So we have to make an adjustment to the code for this particular tool. And it's not that hard to do, so bear with me. The first thing I'm going to do is I'm going to save my project so everything comes back. So I'm going to click on the save button. It looks like an old floppy disk. For those of you who remember getting AOL disks in the mail, that's what that is. I'm going to save it in my workshop materials, just like I'm saving everything else. I'm going to put that in my workshop folder. So I'm giving it a name so I'll remember when it pops up on my list that that's what this is. So I'm just calling my project workshop underscore geocoding. I'm going to save that somewhere where I can find it again, because we're going to have to restart QGIS, so this will save time. Okay, so I'm looking at the workshop materials. So the way we're going to get to this information and how we're going to fix the problem with the plugin is we're going to go to our settings menu at the top of the screen. So settings menu, and then under user profiles, I want to open my active profile folder. What this is going to do is it's going to go into my file system and it's going to find the folder where it's saving things like plugin data. So I don't have to go find it in the depths of my computer. It's just going to open the right folder. All right, so there I am. And now I just need to navigate a little bit. So first thing I want to do is find my Python folder because this is a Python plugin. So we're going to click on Python folder, and then in that folder, I'm going to click on the plugins folder because this is a plugin. Plugins folder, and then QGIS. If you use QGIS quite a bit, there'll be more things in this folder. I've got a user profile set up, so it's pretty bare. If you're new, yours will look similar. But again, if you use it a lot, you may have a lot of things in this folder. So I'm going to open up the QGIS folder. And then the last thing I need to do is I want to look at this file that's called mmqgislibrary.py. So this is Python script, but don't worry, we're not coding. We're just going to take away a couple characters. So what I want to do is I want to open this with Notepad++, because that is my text editor that has line numbers. So when I open it, it looks like this. So you want to open it in whatever text editor you want to work with. Could be Notepad++, it could be something else. The key thing is it's going to be a lot easier if it has these line numbers on the side, because that's how we're going to easily find the thing that needs to be fixed. So if I scroll down, I'm looking for line number 1898. Again, this is in the workshop materials, so that will help you find things. So 1898. I know it's not good television watching me scroll, but here you go. So what we're looking for is a section of code. You could also do, if you don't have line numbers, you can look for this piece of code that says compare zip codes. You could do a search to find that. So this is the section we want. This is the part of the code that looks at zip codes. And you can see, if you're familiar with Python, you can see it has this hashtag or pound symbol, and that means it's a comment. So the code isn't reading this. This code works. I promise it works. It just is commented out. I'm not sure why, because it helps make this work. So all we need to do is remove this pound symbol from these lines. So from 1898 through 1901. We're just going to delete. So I'm going to position my cursor and just delete these hashtags. Okay, so now it's because my notepad has text highlighting, it changed color. So now I can see that this is going to be active code. Yours may look different depending on your the setup that you've got, and that's fine. What matters is you took away those hashtags on those 4 lines of code. And now we're just going to click save. Do not panic about changing the code here. If we screw this up and it no longer works, we can always reinstall the plugin and start from scratch. So there's nothing you can do here to break this permanently. So don't worry. I know this is a little scary if you're not familiar with coding. I hesitate to do this in a workshop, but the good news is once we do this, you'll have it set up and then your plugin will work very well. Okay, so we deleted those extra hashtags. We click save. I'm going to go ahead and close this because I don't need that anymore. And now the last thing we need to do is restart QGIS just because we've changed the plugin code. So I'm going to go ahead and X out of this. We saved it. So if it asks you, do you want to save? Yes, you want to save. Go ahead and save it. And then I'm just going to restart QGIS. It's going to take a second to load. It's remembering my profile that I set up. So I'm going to go ahead. If yours, sometimes you'll have the preview here and it'll say like, oh, you were working on this. Do you want to open it? Go ahead and click it there. Because of the profile that I have set up, it's not doing that. So I'm going to go ahead and click open project. And I'm going to navigate to where I saved it. Not in my G drive, D drive, workshop data. So there's my file. I can always navigate to find it there if it's not showing up on my list of things that I was working with before. Oh, I see mine's set with project templates. That's why. So I'm going to go ahead and click on that and click open. That's the long way to go. Okay, so it restored everything I had. Let's try our plugin again. So I'm going to click on my QGIS plugin. I'm going to go to Geocode. And again, remember, we're using the Geocode from Street Layer. I'm going to click on that. And so we're going to do exactly what we did before. So we're going to navigate and we're going to find our cleaned addresses that are actually clean this time. Thank you guys for finding the problem with that. We know that the defaults generally look good, but I'm going to make sure that they are what they should be in case it made a different decision this time. Street layer should not be geocoded addresses. It should be this layer. So the edges layer. And again, we're going to take a look at all of these options and make sure that it picked the right thing. Okay, again, it wants to put everything in a temp file and we're going to tell it no, we're going to save it somewhere so we don't lose that data. So geocoded addresses, I've already got it loaded, so I need to give it another name. Let's say, I'm going to call it new code just because that way I'll remember that this is after I changed the code. In general, there are some other naming practices that would be helpful. And let's see, also I want to change my not found addresses. So addresses not found, and then I'm going to add new code at the end of that, just so I remember that these all go together. Again, with projects, it's a little bit easier because you kind of have a standard way of doing things, but with workshops, it's not as clear cut. So, okay, so we've got that set up and now I'm ready to click apply and see what it does. Okay, so we can see, thank goodness, it found 5 out of 5 this time because you guys helped me fix my addresses to be correct. So I'm going to click close, and then I'm going to uncheck my geocoded addresses from before because we don't need to look at those. Look what happened. It's a little hard to see because QGIS picked UC Davis yellow for everything, but there are not any points in West Sacramento or in Woodland, which is good. So if I zoom in now to the downtown area of Davis, all of my points showed up in the right place now, or at least pretty close. I mean, if I actually went through and looked at all of the addresses, like I know this is 3rd Street and I have a couple addresses there. And anyway, just because I know downtown Davis, I can tell you these points look a lot better, especially because they didn't show up in the wrong city. So this is an example of the iterative process that we have to use while geocoding. I have never, ever had a geocoding process that went through smoothly on the first try. Never. I cannot tell you, like, there's never, ever been one that actually worked. Even with simple data like this that I would expect to work on the first try, it's always iterative. So when you do this, do not feel bad when you take real world data and half of it doesn't work on the first try. You will have things that need to be adjusted and fixed, and you know, you'll have to make changes, and that's normal. So it's good to see this in a workshop. But anyway, this looks pretty good. What I could do is I could bring in other background layers to help me assess how this works. I could also, if I open up, I just right clicked in the blank space. If I open up my layer styling panel, I can make sure that my geocoded addresses are there. I could tell it to label, like let's say it probably will help me to know so it's decided to label it with a street, which is what I was going for. So I could pick off the list what attribute column I want. But so, okay, this looks good because I know I'm familiar with downtown, so I can tell this is 3rd Street. I don't want to have the edges label the roads because every single one of these little pieces is going to get labeled and it's going to be overwhelming. But so I can see if I know my downtown grid, this is 3rd Street, that's 1st Street, E Street, G Street, that all checks out with my local knowledge. So these look pretty good. Also, I could change it. Maybe I want to label it with a restaurant name. So if you're more familiar with downtown Davis, you'll look at this and be like, oh yeah, that looks pretty good. I think that's generally in the right spot. So now we've been through that whole process where we've taken our data, we've cleaned it to the best of our ability at the time. Then we've run it through the geocoder, and then we've assessed our results. So we took a look at our data and we said, okay, I know Carlos just said rest in peace, Davis Pinata. Unfortunately, Pinata no longer exists because of COVID times. So good. Anyway, hopefully they'll be back. But so we processed this data. We have assessed how good we think the quality is. And then we started to formulate some hypotheses about why our data didn't work the way we wanted it to. And in this situation, we had 2 hypotheses. One was I messed up doing my cleaning and didn't clean it right. So we fixed that. That was pretty straightforward. The second thing was we need to look at our tool and say, why is the tool not operating the way we wanted it to? And then if we take a look and we dig a little bit, we can ask on like forums and things like that. We can look at the repository for the code and see what the coders are talking about, and we can make an assessment about how to fix things ourselves. Sometimes we can fix it ourselves, sometimes we need to find another tool, but in this case we fixed it. And then we rerun the data and again assess the quality and say, okay, now we think this looks pretty good. Okay, so now you've sort of seen the process for how geocoding works, and you've worked with a very specific tool, in this case, the QGIS plugin. You can swap out different parts of this process though. So when we are looking at, I'm gonna bring back this thing over our workshop materials. So when we're looking at our process diagram, we can swap out the different parts of this, right? So with our input data, we may have a different cleaning process, for example, or with our geocoder, we might, instead of using QGIS for our geocoder, we might decide to use the Tiger geocoder instead. And that's gonna have a little bit of a different flavor to it, but we can swap out those pieces. And then our output assessment is gonna be different depending on our data, the data that we're working with, but also our quality needs. Like, does this really need to be geocoded very precisely, or is it okay if there's some wiggle room? Like, a lot of times we don't need to know exactly where a person lives. If it is somewhere on the street, it's good enough. Sometimes if it's in the same city, it's good enough. So we can assess our quality needs and swap out different parameters for that last bit too. So this is one of the things that makes geocoding challenging, is not only the technical aspects, but the fact that you can swap out all these different parameters and sort of change up the process as you need it. So with that, we've got about 20 minutes left. I think what I'd like to do is open up the forum for questions. So if you have questions about geocoding in general or other tools, go ahead and type them in the chat and I will answer those as best I can, and also, you know, call on our helpers too for their knowledge. So I'm seeing the question, do we need to change the Python code every time? No. So it will remember, since we saved it, it's going to stay on your system. The only caveat to that is if you reinstall the plugin, it will do a refresh and you'll get the code from the repository. And also sometimes if you update your QGIS version, you may have to reinstall plugins. And again, you'll have to go through that process. The good news is that it's documented not only on GitHub, but it's also in the workshop notes. So you can always refer to that as you need it. When I get a chance, things are always chaotic, and you know, when you're working, there's always too much going on. So I really want to get in touch with Michael Min and ask him why the code is this way and suggest that maybe he fixes it. I met him over the summer. So that's the cool thing about the open source community, is you can actually meet the folks who do the programming and chat with them and ask to help. Okay, so got a question for the OSM based geocoders, do they use the same logic? Yes. So all geocoders have this process that we've got here. Let me make this a little bigger as I point to things. So inside a geocoder, almost all of them have a similar situation where there's an address normalizer that takes in your address, and then there's a piece of software. Once your address is normalized, it compares it with the road network. Almost all of them work that way. If you're using open addresses, you're doing more of a database fuzzy matching kind of situation on address names in your data set versus addresses in the address database, but they're all kind of similar. So you normalize your address and then you match it against either a road network or a database of addresses. So they'll basically, you could use OSM data in place of the road network like we did today. We use census data, but you could potentially get OSM data that was formatted correctly for the edges where we have the from and to and stuff like that. You can actually swap that in and use OSM data there, or you could find another service that, for example, if you're using a third-party service, you can use OSM that way too. So really, that's why I said like these things are like, you can swap them out. It's like plug and play. Like I want to use a different road network. Okay, as long as it's formatted right, I can do that. So you definitely can use OpenStreetMap or OSM for your road network. You just need to make sure that data you download is formatted correctly and has all of those pieces of information about the edges and the from and to addresses and things like that. All right, so I've got a question saying, can you talk a little bit more about your process for dealing with addresses that are wrong to begin with? For example, you had Three Ladies Cafe address as 1300 G Street. So was that just the wrong address for Three Ladies Cafe?
Well, the address you gave us was 130 G Street, which was the correct address, but if it had been typed in your database as 1300,
I see.
Can you tell about that process?
Okay, so if somebody who provided your addresses or you had some kind of typo or something like that, so part of the data, like the assessment of your data is it's easier to do the assessment when you know your data set very well, which is why for the workshop, I only gave you 5 addresses because you can get to know this data set pretty well. Even if you're not familiar with Davis, you can be comfortable with 5 restaurant names. It gets harder when you're like, a couple years ago, I had, a data set with like over 2,000 addresses. I'm not going to necessarily know that it's wrong, but what will happen is, for example, given my local knowledge of G Street, I don't think there is a 1300 block. So what might happen is everything geocodes except, the one point for Three Ladies Cafe. And then I start digging and I'm like, okay, why is that? So I might, in this case, because this is a public entity, I might go and look at, their website or look it up on Google Maps and see like what's wrong here and then make that assessment that way. But it does get harder. Like if, say, it was supposed to be the address is 130 and I had 140, or maybe I had like 200, it'll still be in the general range. And so I might not pick that up. This is the challenge with geocoding, especially the more data you get, the harder it is to proof and make sure that everything is 100% correct. So there's trade-offs there. I definitely will say that geocoding is not for your needs if you need it to be very specifically correct. Like this is definitely not, something that you would be using if, you were directing weapons, where you need to be very precise. This is not the case for that kind of data processing. You need other data sources. This is for ballparking where something is. So maybe I don't care if Three Ladies Cafe is on the right block or not for my analysis. If I'm doing something like turn-by-turn directions, that will be problematic because it'll send someone to the wrong block. But in that case, you would spend a lot of time building up your road network data set and proofing your input data and things like that. So hopefully that helped answer a little bit that it's really not that easy to proof these, but it's you kind of use the clues about when stuff doesn't go well. The other thing you can do is pull out, like if I had 2,000 addresses, and in this situation, because I have a data set that is restaurants, maybe I'll pull out like a quarter of them and check those very precisely. Like I'll get my, staff or something like that to go through these, or a student worker or something like that to check them and make sure that they all look like they're pretty good. So you can do quality control that way too. Pull out a certain subset of them and make sure that they got in the right spot. All right, so hopefully that helped, Naomi. I'm gonna take a look at some of the other questions. So the question is, does the not found addresses tell you why it wasn't? No, it doesn't tell you why. It doesn't know. All it knows, and for this particular tool, this one doesn't have the option to tell you why it didn't work. It just tells you that it didn't work. That's all you know with this particular tool. Other tools have quality assessment. Like if you use the Tiger geocoder, it actually gives you a code for when it, like whatever output it gets, it'll tell you sort of a range of, it's kind of weird with that one. It's like from 0 to 106, I think. And the bigger the number, the worse it is. So if something gives you a 106, something went really wrong. But this particular tool doesn't have that, but other ones do. So the Tiger geocoder can tell you how well it did, and like some of the commercial tools will tell you not only how well it did, but what level it geocoded to. So it'll say like it geocoded to rooftops and things like that. That can be really helpful. But in this particular tool for QGIS, it does not say why. You kind of have to use your sleuthing skills and figure out what happened. All right, so I'm seeing a comment that you can always spot check a couple of addresses, right? So you can always, for the checking process, you definitely want to check and do a few at least for very specific, addresses to check and see if it really did do a good job, if you think it's right. Also knowing that there's going to be a little wiggle room, that in this particular tool, we're not matching to parcels the way that some tools can. So if it's close, it's probably as close as you're going to get. But you can look for those broad stroke problems. Like we know all of our addresses are in Davis and some of them went to Woodland. That's problematic. That's pretty obvious. So you kind of start at that level and kind of work your way down into specifics. And again, I have every single time I've geocoded, I process data more than once. There's always an iterative process with geocoding. It's pretty rare that you would get a data set that worked right off the bat. All right, so I'm looking at some more questions here. So I'm seeing a message from Cam that says, I'll add that some geocoding tools like the US Census Geocoder can give results in the centroid of a zip code or city. If an address is weird, it can't be matched with a specific street. Not as exact, but it can be good enough depending on the project. That is true. So like the Tiger geocoder will do that too. If it can't find, it sort of looks at the address as a whole. And if it can't find like your address, like 130 G Street, it'll be like, well, I can't do that, but I can find Davis, California, and it will put your marker right in the middle of Davis. So if we did a whole bunch of Davis addresses and they didn't match and we're using the Tiger geocoder or potentially the Census geocoder, it will just pile them up in the middle. So you get a whole bunch of points in the center of the city or the zip code or the state, depending on what it can find. So you want to be careful of that too. They may look great, but then when you zoom into like the center of California, it's like, whoops, there's like half my data ended up there. So you want to be careful about those kind of artifacts that can happen with that kind of sort of leveled type matching, where it's kind of like best, better, kind of not great. You'll still get a place, but it may not be what you want. So you want to be careful about that. Just because it matched doesn't mean it did a great job with it. So getting a question about QA algorithms and geocoding. I'm not familiar with them, but it doesn't mean they don't exist. I don't geocode super frequently, but you definitely could find some tools, I'm sure, to help with quality control and assessment on the data sets themselves. I'm seeing Alex has some answers to that. Alex, do you want to tell us a little bit more about what you know about the quality control algorithms?
I just remember a study out of USC a while back that ran the same data set through 5 different geocoders and compared their answers.
Mm-hmm. Yeah, so there's definitely ways to check with these, and there's probably some good papers out there in the academic world about how to do the checking and things like that more systematically, which is really helpful when you've got a giant data set, like, you're working in the thousands of addresses. So I've just posted in the chat window some links for you guys to follow up. So the workshop videos get posted on the Data Lab YouTube channel. And this one will get posted probably next week. We've got quite a few workshops going on for Love Data Week, so it'll probably take us a little while to get all of them posted, but check back there later if you want to rewatch this video. Also, the schedule for Map Time Davis is in the link that I've just sent as well. So if you wanted to come to other workshops, those are available. And like I mentioned earlier, next week, next Tuesday, we'll be having a, just general discussion. Imagine sitting at a table, bring a cup of coffee and your notebook, and we'll chat about other geocoders and other processes for geocoding data. I can show you the Tiger geocoder and things like that if you're interested in working with a PostGIS database. Tools like that are better for bigger data sets. The one we're working with today is really good for small, like county level type data, but if you need more than a couple counties, using a bigger tool like PostGIS geocoder is going to be a little less frustrating if you're trying to work with bigger data. So feel free to join us next week. Again, it's going to be a more informal situation. So come and be prepared to chat and talk. I'll hang out. We've got, another 10 minutes or so. I'll hang out and answer any more questions you guys might have, but I'm going to go ahead and stop the recording now and just say thank you all for attending. I appreciate it. It's fun to see all of you guys from so many different places. Stop my share and stop recording.